We will continue to see what options we have when working with sheet metal. We come up here, click the option window, and we will also click sheet metal. We click the plus sign to expand. Here we have sheet metal. In this group we have bend reliefs, and we will look into this later on because I will explain what it is by showing how it works. And it's easier to show than explain in words, so we will leave this section for now. Then we come to bend radius. Select the inside radius to be used for new sheet metal bends. Well, now it's selected use minimum bend radius of part. There is a stock table here that we have predefined sheet metal qualities and also materials. And for instance, this one, cold rolled steel 24, it has a thickness of 0.610 and minimum bend radius of 1.219. And that is my default sheet metal stock. You can see it here because that one is selected. So every time when I drag a new stock on the scene, I will have this one. So it is here that you will select what will be the default sheet metal stock that I drag and drop on the scene. So when it comes to minimum bend radius, it depends on the sheet metal and the thickness of that sheet metal you use. It means that the radius will vary. Here, if you check this one, use custom value, it means that if you type in a value here, every sheet metal that you will drop on the scene will have the same inside radius. Even if the sheet metal is 20 millimeters thick, it will have the same radius as a 1 millimeter thickness. So it is better to use this one, because then it will be used as it is predefined here in this stock table. Here we have constraints. Create punch and forming constraints. Well, when we drag and drop a stamp in teleshape or punch in teleshape or a stamp in teleshape onto the sheet metal, you will have two constraints, two dimensions that you can double click and type in a right value to place them in the right position. If you uncheck this one, you will not have those constraints. Then you have to add the constraints manually. When this one is checked, display constraint dialog after drop of punch and forming shapes. Well, that means that if you drop, for instance, a punch in teleshape onto the sheet metal, you will have a dialog window that you have to fill in the dimensions or the positions where you want to place the punch in teleshape. And then when you click OK in that window, the punch in teleshape will be placed on the sheet metal. But I will leave this one unchecked because I want to place the punch in teleshape, and after it is placed I can double click the dimension and position it in the right position. Then we have auto constraint bends. It means that when you add a bend to a sheet metal, a constraint will be attached to the bend and also to the sheet metal. So if you change the length, for instance for this one, change the length of this sheet metal, the bend will be attached to the edge of this sheet metal. But if you uncheck this box and you add a bend and you want to change the length of the sheet metal, the bend will stay where you dropped it. And so it will not be attached to the sheet metal. So that's why it's good to have this one checked. Then we have advanced options. Here it says that when I drag a stock and drop it on the scene, the stock will have this size. But I will change this one to 200 by 200 millimeters, like so. So next time I will drag a stock onto the scene, that stock will have the size of 200 by 200. Then we have bend allowance. This is the IN 6935 standard. It is a standard that calculates how the bend should be calculated when you unfold the bend or unfold the sheet metal. How much material will it be used when you unfold or to create the bend? Some companies may want you to use this standard, but there is also a formula predefined in IronCAD, and that formula is good enough in most cases when you work with sheet metal in IronCAD. Here we also have punch positioning mode. New punch on bend features are positioned with respect to the flat. I will cancel this one. I will move this window and go back. This means that if you drag and drop a punch on the sheet metal, and it will also go through the flange, IronCAD will calculate how will it look like when you unfold this sheet metal. So it will calculate how it will look unfolded, and IronCAD will also calculate how it will look when it's folded. So that's why it's good that this one is checked, because you will have a right position of the punch, and you also have the right position of the punch when you unfold the sheet metal. Then we have bend corner treatment. Specify the setback value used to create corner treatments. Well, if you want to create a miter flange, there will be a small gap in the corner between the two flanges, and that is the setback. And this is the default value when you create a miter flange is 0.1, and if you want to have a wider gap, you have to change the value here. So I will type 200 by 200 here, like so. I will also click OK. Then we come to the stock. Here we have the stock table. It's a text file. This text file you can open, and you can add your own sheet metal quality or the thickness if you want to add a new one. For instance, my default one is cold rolled steel 24. Is this one that is checked here, and it has a thickness of 0.610, and the minimum bend radius is 1.219. So here is where you select the default sheet metal that you will drag from the catalog and drop onto the scene. So here you can change which one you want to use as a default. If you come down here, you have also a tool table. That's a text file for the stamp and punch IntelliShapes. And this one is also editable. You can go in and add your own design for the punches or the punch IntelliShapes, and also for the stamp IntelliShapes. But it's important that when you edit these text files, you will edit it in the right way. Otherwise, it will not work. And it's also important that you will make a copy of the original. If you make some mistakes in the new one, you can load the old one so that you will have the default sheet metal stock here. Well, I will close this window. I will click OK. Then I will create a new scene, and I will drag a new stock or new sheet metal, drop it here. And then when it's selected, I will right click Part Properties and Sheet Metal. We see now this is the default sheet metal that was chosen there in the option window. A cold rolled steel 24, thickness of 0.610, and it's a minimum bend radius of 1.219. And here you can select a new stock. And if you select a new stock here, it will only change the stock that is selected here in the scene. It will not change the default stock when you drag from the catalog. And here, thickness change refers to stock location. So if I select a new stock here, I will select it with another thickness. Let's see now. I will change to perhaps with this one, a thickness of 3 millimeters. Click OK. Now the thickness change refers to stock location from the center lines. It means that when I click OK here, the thickness will expand in both directions from the center line of this sheet metal. I can also choose that it will change the thickness from top and downward or from bottom up. It depends on if this sheet metal is attached to another part in the scene. Perhaps I want to change the thickness bottom and upward, or it is attached at the top. I want to change the thickness from top and downward. And here you can also change that this sheet metal will use the DIN standard for bend allowance. Here we have also the K factor, and that is important to calculate the bend allowance. So here we click the show rule. We see that this is the formula that are used in IronCAD, and in most cases it is good enough, because the formula is, this is angle, this is radius, K factor times thickness. So that is how it is calculated. Well, I will click OK here, and when I do that, you will see that the sheet metal will change the thickness from top and downward. So I click OK, like so. Well, now we have gone through the settings and the options you have when you're working with sheet metal in IronCAD. So in the next video we will continue, and we will also create a new part in the scene.